All right, let's just jump right in. We're going to tackle one of the absolute biggest questions in tech right now. What is actually going on inside the mind of an AI? You know, we use AI every single day, right? These big, large language models, LLMs. They're writing emails, coding websites, making art for us. But if you ask how they're actually doing it, well, things get fuzzy. And here's the wild part. Even the people who build them don't have all the answers. It's a genuine mystery.
So this whole mystery, it's famously known as the black box problem, and trying to solve it has sparked this incredible new field of science called mechanistic interpretability. You can basically think of these researchers as AI detectives. They're the first ones on the scene, crafting the tools they need to peek inside and figure out what's really going on.
And the problem is really this simple. We see what goes in, our prompt, and we see what comes out, the AI's answer. But that whole middle part, the part where the thinking actually happens, it's just a blur. A massive, hidden world with billions of connections, all firing at once. It's a complete black box.
Okay, so if we're going to be detectives, what's the first thing we need? A map, right? We have to get a basic layout of this strange new digital territory before we can even think about exploring its secrets.
So here's the 10,000-foot view of how an LLM thinks. First, it takes your sentence and chops it up into little pieces called tokens. Then, and this is key, it turns those pieces into numbers, special numbers called vectors that hold their meaning. After that, these numbers go on a journey through dozens of layers, a kind of thinking core. Imagine it's all flowing down this big data highway called the residual stream. And finally, at the very end of the road, the model takes those super refined numbers and turns them back into the next word it's going to write.
All right, we've got our map. Now for the fun part, the investigator's toolkit. We're talking about the incredible methods these AI detectives have come up with. And this isn't just about watching from a distance. No, this is about getting right inside the machine while it's in the middle of thinking.
And man, they have cooked up a whole arsenal of brilliant techniques. They can use these things called probes to basically eavesdrop on that data highway. They can pinpoint which little neurons are the most important. They can even gently nudge the AI's behavior. But one of the most powerful tools in their belt, and we're going to look at this right now, is something called ablation.
And this just shows you how powerful ablation is. Seriously, it's like performing precision brain surgery on the AI. Look at this. On the one hand, with everything on, the model gets it right. Capital of France is Paris. Easy. But then they turn off just one tiny little component, and suddenly the model says the capital is Lyon. By doing this, by seeing what breaks, researchers can figure out exactly what each little piece of the AI's brain is doing. It's genius.
Okay, so we have the map, we have the tools. Now for the payoff. What happens when we actually use them to look inside? Honestly, some of the discoveries they're making, it's the kind of stuff you'd expect to see in a sci-fi movie. And the pace here is just breathtaking. I mean, you have to remember, just a few years back, a lot of this was pure theory, just ideas. Now, we're seeing huge, mind-bending breakthroughs every single year. It's completely rewriting the rulebook on how we think about AI. This quote here points to a really huge moment. See, for the longest time, the big debate was, do these AIs actually get it, or are they just really, really good at memorizing patterns? Well, this research settled it. Scientists looked inside an AI that was trained on the game Othello, and they found a complete working model of the Othello board. It proved once and for all that these things aren't just parroting back answers. They're actually building little models of the world inside their own digital minds.
And it goes way beyond just board games. I mean, get this. They found individual neurons that seem to represent concepts like space and time. They've found the AI's internal model of a chessboard, sure, but also its estimate of how good its opponent is. And maybe the wildest one of all. They're finding representations of emotional states that actually line up with psychological theories about how humans feel. It's incredible.
Okay, this next one is, well, it's a bit unsettling, but it's super important. It's this idea of latent knowledge. What it means is that an AI can know the right answer, but say the wrong one. It can hold a truth internally while spitting out a lie. And as you can imagine, for anyone working on AI safety, this discovery is a huge, huge deal.
So researchers aren't just passengers watching the scenery go by anymore. Now they can actually grab the wheel. They can inject a tiny targeted signal, this steering vector, right into that main data highway we talked about. And by doing that, they can actually control the AI's behavior in real time. It's like whispering an instruction in its ear mid-sentence, telling it to be happier or sadder or even to lie. Okay, so this is all really cool, mind-bending science, for sure. But it's way more than just a cool experiment. Cracking open this black box has huge, real-world consequences for every single one of us. And here's the bottom line, why this matters so much. When you understand how it works, you can make it better. First, there's safety. We can spot and stop risky behaviors before they happen. Second, reliability. We can figure out why AIs hallucinate and make them more truthful. And third, efficiency. If we know which parts are doing the heavy lifting, we can get rid of the rest and build smaller, faster, and more powerful AIs.
And then there's this final, fascinating twist. This might not just be about understanding AI. It might be about understanding us. In one study, scientists actually compared the brain scans of people listening to speech to the internal workings of an AI doing the same thing. And guess what? They found spooky similarities. It suggests that by studying these digital brains, we might actually unlock some secrets about our own. But let's not get ahead of ourselves. For all of these amazing discoveries, we have to be honest. The big mystery is still very much unsolved. The detective story is really just getting started. Right now, we're really good at explaining one little piece of the puzzle. We can look at a tiny, specific behavior and figure it out. But trying to understand the whole thing, an entire model like GPT-4, the scale is just unimaginable. It would take way too much time. And that's exactly why the big focus now is on building automated tools, basically building AIs to help us understand other AIs.
And that really leaves us with the big lingering question, doesn't it? As these artificial minds keep getting smarter and more complex at an incredible rate, can we keep up? The race is on, and it's not just about building better AI. It's about making sure we never lose sight of what's going on inside.